Okay, last few examples here. Example 8 says h is a twice differentiable function. H prime is positive, h double prime is positive. So this is a similar problem to example number 7, all right, where we don't have what h is, but we know that h's derivative and second derivative are both positive. Okay, so what does this mean? It means that our function is increasing, and also the rate at which our function is increasing is increasing. Okay. All right, so what do we know? We know that h of 3 is 15. We know that h of 4 is 19, and we have to state a possible value for h of 5. Okay, well, we know that our function is increasing because the derivative is positive. And that makes sense that we're at 15, and then when x increased by 1 unit, we bumped up to 19. So our function is increasing. Okay. Now, we also know the rate that we're increasing must be increasing. So how much did we increase by? Yeah, we increased by 4 units, which means that when we go from 4 to 5, right, we're trying to find a value of h of 5, we need to increase again, and it has to, the rate that we're increasing must increase. So we have to increase by more than 4 units. So we could increase by 4.1, we could increase by 5, we could increase by 1,000. Those are all valid answers. Okay? We just need to have a number that's larger than 4. If you had increased by 4 or less, that would be incorrect, because this tells us right here the rate that we're increasing must increase. So h of 5, probably the most common answer, would be if we would just add 5 units this time. We were already at a value of 19, so we add 5 to that. So one possible answer for h of 5 would be 24. And what would happen in a question like this on the exam or on the homework is the test writers would give you 4 options for multiple choice, and one of the 4 options would be 24, 25, or 26, and all the other options would be 23 or less, because if we added 4, again, 19 plus 4 is 23, we know that we have to add more than 4, so 23 is the final number, which would be incorrect. Basically, if you have any number here that is greater than 23, then you would be correct. The most common answer would be 24. All right, so doing the same thing here with b, we see let g be a twice differentiable function. G prime is greater than 0. G double prime is less than 0. Okay, so once again, our function is increasing, but the rate at which we're increasing is decreasing. So the rate of increase is decreasing. So how much did we increase by the first time around? Yeah, we only increased by 1 unit. But now the rate that we're increasing has to decrease. So we have to increase by less than 1 unit this next time around. All right, so we can increase by half a unit, which means that g of 5 would be where we were already, 7. We're going to go up a half a unit. So g of 5 could be, because again, it's a possible value, g of 5 could be 7.5. And in fact, g of 5 actually has some restrictions right here. We know that the value of g of 5 has to be bigger than 7, because g of 4 is 7, and we're increasing. So we got to have a number that's bigger than 7. But we can't increase by 1. We have to increase by less than 1, because we already increased by 1, and the rate that we're increasing must decrease. So if we were to increase by 1, that would give us 8, but that's not good. It has to be a number less than 8. So basically, any value between 7 and 8 would be acceptable here. And again, you might have 7.5, somebody else might have 7.25, both of you would be correct. Last but not least, we can go with some particle motion. Right? So the table gives selected values of the velocity, v of t, of a particle moving along the x-axis. So at time 0, the velocity of the particle is -1. At time 1, the velocity is 2. Time 3, the velocity is 3, so on and so forth. At time 0, the particle is at the origin. Which of the following could be the graph of the position of x of t? Well, we know that the velocity is the derivative of x of t. So, what's going on with our velocity? We see that our velocity is negative, and then positive, then 0, and then -4 again. So our velocity is negative, and then positive, and then negative. So the derivative, if you will, the derivative, f prime, think of it this way, is negative, and then positive, and then negative. Which means we need a function which is decreasing, and then increasing, and then decreasing. It all goes back to these connections. So, which of these graphs is decreasing, and then increasing, and then decreasing? This graph is increasing right away. It's out. This graph is increasing right away. It's out. This graph decreases, and then increases, and then decreases again. So that's a possibility. D increases, and then decreases, and then increases. It does the opposite of what we want. That's out. Finally, E, we see decreases, and then increases, and then decreases. So we've got a choice here between C and E. Okay, well, let's go a little bit further here. We see that the derivative is equal to 0 at time t equals 3, which means we need a horizontal tangent line, right? The derivative is the slope of the tangent of the curve. We need a horizontal tangent line at x equals 3, or t equals 3. Going to our two choices, 1, 2, 3, we've got a horizontal tangent line. 1, 2, 3, we've got a horizontal tangent line. So that doesn't help us out. What else do we know? Well, we know that our derivative, our slope, if you will, is -1 at the very beginning. Right? So, and then it will be -4 near the end. Well, let's take a look at our two graphs. Here's the initial slope of our tangent line for C. Here's the initial slope of the tangent line for E. Looking at these two, doesn't it seem like this slope is close? Actually, I made it a little too steep. I think it should be more like that. That slope looks a little bit more like a slope of -1 than this slope does. Okay. And even further than that, if we look at us, we know that at 4, our slope has to be -4. So if we look at the C graph at x equals, we have this as our slope at t equals 4, and then over here we have this as our slope. Which of those two seems to be closer to a slope of -4 based off of the tick marks that are on our graph? Well, it seems like E, this looks more like a slope of -1, and this looks like more like a slope of -4, as opposed to this graph right here. Our answer is E.